right, so the first way that we learned how to do this was what? Yeah, we graphed them, right? And we found where they intersected by their graphs. Okay, then what did we do for the last couple days? Substitution. We substituted whatever y equaled or whatever x equaled in to make that work. So if you remember, what's the easiest way to do graphing when my equations look like what? What do my equations have to look like to put them into my calculator? Just y equals, right? So if I have y equals blah, 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 and y equals blah, 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 those are easiest to do by graphing, right? Okay. And then with substitution, we needed one of them to look like what? Either y equals or x equals. So usually that one looked like y equals, and then the other one was usually in standard form, and it looked like that, right? So then we used substitution, because it's never real fun to solve this for y and do all that stuff, right? Okay, so today we're going to talk about elimination. Okay, and elimination is sometimes called linear combinations, but I will always call it elimination. But if in your directions on like a worksheet it says linear combination, they're meaning elimination. Okay, because sometimes you get equations that look like 2x plus 4y equals 8, and then your other equation is like 6x minus 4y equals 12, right? And if you wanted to graph it, you would have to solve both of them for y, right? And if you wanted to use substitution, you would have to do at least one of them for y, right? That's kind of a lot of work, right? Okay, so elimination, if we have two equations in standard form like this, we're going to be able to use elimination. Okay, we're not going to have to move stuff around in order to do it. Deal? Yes? Okay, good. All right, so what we are looking for when we use elimination, we're on like page 39, I think. Okay. What we're looking for when we use elimination, we need one of my variables. What's my variable? X or Y. Yep, those are my letters, is my variable. Okay, to have the same coefficient. What's a coefficient? The number that's hooked onto the letter. Yep. Okay, so in this case, if I look at my x's, do they have the same coefficient? Nope. Okay. If I look at my y's, do they have the same coefficient? They kind of do. Okay, they're both 3's, right? Okay, so we want them to both be 3's, but we want one to be positive and one to be negative. Do I have that? With my y's, right? Okay, so if I have that, what I do is I just add my two equations together. Okay, so we're going to put a plus sign right here and draw a line underneath. Okay, and then we add these together. What's 4x plus 2x? 6x. What happens with my y's? What's 3y plus a negative 3y? They cancel out. Equals, what's 16 plus 8? 24. Now what do I have to do? Okay, let me ask. Okay, how do I get x by itself? Divide by 6. So x equals 4. All right. So now I have x, but what else do I need? I need y. So how am I going to find y? Well, what we can do is we're going to plug it back in to one of these equations. Okay, and here's the deal. It does not matter which equation you plug it into. I usually just pick the top one just because. Okay, if I were to pick the bottom one and plug it in, I'm going to get the same answer. Okay, but if I pick the top one, I'm going 4 times, what am I plugging in for x? 4 plus 3y equals 16. Some of us aren't writing, and I'm not sure why. Okay, so what is my 4 times 4? So I have 16 plus 3y equals 16. Now what do I have to do? Subtract 16. 3y equals 0. Then what? Divide by 3. So y is 0, because 0 divided by 3 is 0. So my intersection point, or my solution, is, what's my x? Comma, what's my y? So my solution is 4, comma 0. Okay, this is my favorite method. Okay, I think this is way easier than substitution. Do you guys think it's easier than substitution? Okay, I just think it's less confusing than substitution. Okay, but some other people are like, ooh, substitution's easy, whatever. Okay, and that's okay too. That's kind of a personal preference thing. Okay, so for those of you that are trying to write this on the side of your paper, this is on page 39. So these are, yep. All right, so if I look at my 2 equations, okay, if I look at my x's, do I have the same coefficient, 1 positive, 1 negative? I do, okay? So as soon as I have that, what can I do with my 2 equations? I always add my equations. Okay, so 3x plus a negative 3x is, it's 0. Those cancel. Okay, 2y plus 4y, 6y equals 7 plus 5, 12. Divide by our 6y equals 2. Now what do I do with that 2? Plug it back into one of the equations. Does it matter which one? It does not, right? So like I said, I always pick the top one. I'm not really sure why. It just makes sense for me to plug it. What am I plugging it in for? Y. So 3x plus 2 times, what is my y? 2 equals 7. So 3x plus 4 equals 7. Now what? Minus 4. 3x equals 3. Divide by 3. X equals 1. Therefore, my solution is 1, comma 2. What do you think so far? So far, so good? Okay, well, if it's so far, so good, why is Alexis the only one answering any questions this morning? Come on, wake up! All right, we're looking at this guy. Okay, 4x, so do my x's have the same coefficient? No. Okay, do my y's? Yep, is 1 plus and 1 minus? Yep. So then I do what? Add, good. So 4x plus 3x, 7x. What happens to my y's? Okay, so those cancel. So 7x equals 14. Divide by 7. X equals 2 again. Okay, and then we go and we plug it in. So 4 times, what is my x? 2. Minus 2y equals 2. 4 times 2? 8. Minus 2y equals 2. Now what? Subtract 8. What do I bring down? Be careful. Negative 2y equals negative 6. Now what? Divide by -2, y equals +3. Good. So my solution is 2, 3. Okay, now we have to talk about a couple more problems that are on your worksheet that have been kind of throwing people off. Okay, so you're going to write these on the back side. Okay, and remember, when I do stuff that I want you to write on the back side, it's not just for the sake of wasting some time. It's because it's on your worksheet and I want you to be able to know how to do it. Right? All right, so let's say I have x plus y equals 10 and x minus y equals -6. Okay, this has been throwing people off because it looks like there aren't any numbers in front of my x and my y, right? But there's actually what? Ones, right? So we gotta look at this. Is there the same coefficient in front of my x? Yeah, there is. They're both 1s, right? But is one positive and one negative? No. Okay, so we can't use it there. What about my y's? Yeah, I've got 1s in front of my y's, and one is a plus and one is a minus, right? So we're good to go, right? Okay, so now what do I do with my two equations? I add them together. So x plus x is 2x. What happens with my y's? Those cancel, equals 4. So now we divide by 2. X equals, oh good, 2 again. I could have sworn. I was hoping for a different number, but I guess not. Okay, so now where am I plugging that back in? Back in for x. So on the top, if I plug it in for x, 2 plus y equals 10. Subtract our 2, y equals 8. So my solution is 2, 8. Okay, one more. Sometimes I'm not going to have a plus and a minus. So if I have, let's say, x plus 2y equals 3 and x minus y equals 6. Do I have the same coefficient with my x's? I do. They're both what? They're both 1. Okay, because remember there's that imaginary 1 in front of them. Do I have the same coefficient with my y's? No, because one's a 2 and one's a 1. Okay, so we don't have anything that cancels out right now, because if I were to add these together, what would I get for my x's? I'd get 2x, so nothing would cancel. So I need, since they're both 1s, what's the only thing I need? I need one of them to be a -1. Okay, so how do I change the signs of something? If I had, remember when I have -y equals -8? How did we get rid of that negative? We divided by -1. Okay, in order to change my signs, what you need to do is you need to multiply everything in that equation by -1. Okay, so when I do that, on top I get -x minus 2y equals -3. Good. And then I can just recopy my bottom, the same thing. X minus y equals 6. Okay? And then I'm done with that part. Now I'm working with this. Because now do I have one positive and one negative coefficient? Yep. So what happens to my x's? They cancel. Negative 2y plus negative 1y. Negative 3y equals 3. Divide by negative 3. Y equals negative 1. Okay, I'm going to plug it into the bottom one just because it might be fun this time. So x minus, what's going in for what? Negative 1 equals 6. What happens when I have a minus? Turns into a plus. So I actually have x plus 1 equals 6. Now what? Minus 1, x equals 5. So my solution is 5, negative 1. Okay, so most of the problems that you do, you're not going to have to mess with. You're just going to have to add and subtract them like this. Okay, there are a few where you're going to have to multiply the top one by negative 1 so that you get one to be positive, one to be negative. Deal?